colleagues. This is the fifth session, second oral session. We will meet with Dubna University Group. In this session, we will meet first principal calculation of geometrical structure and electronic and optical properties of brom-doped cesium tinnic iodide perovskite for photoelectric application by Nematova Delshot, and this next session will be with Sagila Nivukitova, investigation of the optical and the photoelectronic properties of quantum dots for immunochemical analysis. The third session will be with Sagila Nivukitova, the use of quantum dots as fluorescent labels in the immunochemical methods of analysis. The fourth session will be with physicochemical basis, electrophoretic behavior of the quantum dots by Elena Gribova. The fifth one will be hybrid perovskite, methyl nitride, lead iodide bulk crystal synthesis by temperature lowering methods by Kiniv Valdislav. The sixth one will be with Sergeyevich Dmitry, and this will be the use of multivariate data analysis method for selection of Romsing heat storage material based on hydrate salts. The last one will be with Ruhi Rafi'u Zaman and entitled Novel Bimetallic Nanoparticles for Sorption of Mercury 2 from Drink Water, Adsorption Experiment and Computational Studies. Let's start.
Dear colleagues, I am Nematov Dilshod Davlatshoyevich. I work at the Tajik Technical University named after academic Muhammad Osimi. The topic of my talk is first principles, calculations of geometrical structure and electronic and optical properties of brom-doped cesium scandium iode-3 perovskite for photoelectric applications. With rapidly increasing emissions of greenhouse gases into the atmosphere, it's imperative to develop technologies that can generate energy at a low cost to the environment and reverse the currently intensifying climate change. However, to successfully make the transitions from fossil fuels to renewable energy sources, we can no longer rely solely on oxidizing materials, but must focus on synthesizing other classes of materials with improved properties. It's known that the family of perovskite crystals based on halides with a general formula ABX3 have gained great interest due to their efficient characteristics, high absorption coefficients, high mobility of charge carriers, compositional flexibility and high stability due to their wide range of applications. For example, in the creation of solar batteries, photodetectors, LEDs, superpower lasers, 3D, single crystals, thin films, and so on. However, despite the rapid progress made over the past few years in terms of conversation, efficiency, and understanding of the fundamental electric properties of IMX3, perovskite is rather limited. Moreover, it's known that most of these halide perovskites in their pure form exhibit pure activity upon irradiations with light due to the non-optimal band gap. For example, the band gap of cesium-scandium Yo3 in its pure form is 1.3 electrons volt, which is considered not very suitable for photovoltaic applications. Since the task facing the researchers in the directions of solar energy at the present time is the search and development of semiconductor materials with the required value of the width of the request zone. The most common way to hang the conversion efficiency of solar cells is to find the aforementioned band gap by replacing foreign ions and changing their content. Therefore, here we are talking about optimizing the optoelectronic properties of cesium-scandium Yo3 perovskite by doping with brom in its unite cell for photovoltaic applications. In this slide, we show geometrical structures of cesium-scandium Yo3, cesium-scandium Yo2 brom, cesium-scandium Yo-brom 2, cesium-scandium brom 3, cesium-scandium Yo3X brom systems. In the current study, the geometric structures, electronic and optical properties of orthorhombic system cesium-scandium Yo3 X brom X with X 0, 1, 2, 3 are investigated by ab initio calculations within the framework of density functional theory for their use as non-toxic light absorbers in solar cells. Geometrical structure and electronic and optical properties of lead-free mixed halide inorganic perovskite cesium-scandium Yo3X brom X with X 0, 1, 2, 3 have been studied in the framework of density functional theory. The efficient electron exchange and correlations functionals modified Beck-Johnson exchange correlations potential has been applied to the calculations of electronic and optical properties. Geometry optimization was carried out by allowing the relaxations of all the atomic positions in the cell and cell shape. Electron correlations was expressed by the generalized gradient approximation proposed by GGA PBE. 3 to 3 K-point mesh was sampled in the Brillouin zone with Monk-Shor's PEC scheme. Plane wave cutoff was chosen to be 400 electron volts. This slide presents the results of quantum chemical calculations on the study of the structural properties of the above materials. Optimized structural parameters of cesium-scandium Yo3 minus X brom X are summarized on Table 1. Experimental cell parameters of the end members, that is, cesium-scandium Yo3 and cesium-scandium brom 3, were quantitatively well reproduced by the current calculations within typical GGA errors. More than from Figure 1, it's severable that with an increase in the concentration of bromine, the volume of the system decreases This dependence is almost linear. Electronic structure calculation for the models after geometry optimization with WASP were performed by the full potential augmented plane wave plus local orbital package Wn to chi. Calculated electronic total density of state of the above structurally optimized models of cesium-scandium-U3 X brom X are shown in figure 2. Calculated band gaps of these materials are summarized on table 2. The good agreement of the band gap of the terminal elements, that is cesium-scandium-U3 and cesium-scandium-brom-3, with experiments and current calculations, indicates the correctness of our MBG calculations. These calculated band gaps are plotted in figure 3, which suggests the band gap increases linearly as increment of the brom concentrations X in cases scandium U3 X brom X. Least square fitting to the calculated band gap was done, which is also shown in figure 2. This fitted line is expressed by E energy band gap 0.1403x plus 1.3278, from which we can estimate the band gap for cesium-scandium-U3 X brom X with any brom concentrations X. In this slide, shown the partial dosage system of our family of cesium-scandium-U3 minus X brom X. We can watch that these states of atoms, iodium, bromium, cesium, and p states of scandium play the main role in the formation of energy levels of the mixed halide perovskite system cesium-scandium-U3 minus X brom X. Electronic band structures of cesium-scandium-U3 minus X brom X are shown in figure 5. Overall band structures show similar profiles, though the band gap increases as increase of brom concentrations. It should be noted here that all of these materials have direct transitions type of a band structure, which suggests all of these compounds are suitable for the use as optical materials. The optical properties are calculated using optical implemented in the Wn to chi package. Real and imaginary parts of the dielectric constants epsilon 1 and epsilon 2 are shown in figure 6 and 6a and b respectively for all family of the system studied here. Optical studies have shown that doping with brom leads to an increase in optimizations of the band gap, but the absorption capacity of these materials practically doesn't change. Figure 7. Calculated optical absorption is strong evidence of absorption in the visible and infrared regions. The results obtained here can facilitate understanding of some features of the optical properties that are important for the practical application of the systems under study and may turn out to be of interest to researchers looking for materials with specific optical characteristics. Based on the above characteristics, we can say that these materials are favorable for photovoltaic devices. The first principles results obtained satisfy the criteria for brom-doped cesium-scandium-U3 to be a unique material in sensitized solar cells. Summarizing the discussions on the optical properties, As indicated above, there are no data available yet in the literature with regard on the optical characteristics of the perovskite system here investigated. Nevertheless, the obtained results may help to understand some important features of the optical properties which are important for the practical applications. The new perovskite system studied above may prove the search of a criteria for the candidate materials that passes the optical characteristics favorable for the photovoltaic design.
Hello, my name is Nasirov Pavel, and I will report to you about investigation of the optical and photoelectronic properties of quantum dots for immunochemical analysis. Technologies using semiconductor nanoparticles are gradually finding their application in completely different scientific fields: medicine, printing, photovoltaics, electronics. Quantum dots are semiconductor materials whose charge carriers are limited in space to all three dimensions. Quantum dots have a number of unique optical properties, such as high intensity of fluorescence in a narrow wavelength range, high photostability, resistance to chemical degradation, and so on. Currently, all methods of quantum dot synthesis may be divided into physical and chemical. Physical synthesis methods need expensive equipment, so chemical methods are the most promised. The general concept of the quantum dots chemical synthesis consists in obtaining ion source of the semiconductor material composing of the core of the particle, with the addition of surfactant stabilizers that passivate the surface of the particle and prevent the aggregation and the build-up of semiconductor shells in order to reduce the effect of quantum dot structure defects or their properties. The chemical methods of quantum dot production include colloidal methods of nanoparticle synthesis, which are carried out according to the general principle, in three stages: formation of nuclei in a supersaturated solution, growth of nanocrystals embroiled by diffusion, repeated dissolution of smaller nanocrystals to release monomers, and growth of the total quantum dot size. There are two main types of colloidal synthesis: aqueous and high-temperature metalorganic. Quantum dots metalorganic synthesis consists of high-temperature injection of precursors into a solution of non-polar organic solvent. The advantages of this method include a small variation in the size of the original quantum dots, as well as the high intensity of the luminescence. However, it's also worth nothing to relative complexity of this method and toxicity of the reagents, which are necessary for its implementation, which obliges the synthesis in a well-equipped room with using personal protective equipment. In addition, in non-polar solvent, it is impossible to cover the quantum dots with a hydrophilic stabilizer immediately. In order to obtain water-soluble quantum dots by organometallic method, additional modification of quantum dot surface is required. However, they often lead to reduction of quantum dots quantum yield. Quantum dots obtained by organometallic synthesis cannot be further used in aquatic environments due to their surface hydrophobicity. Hydrophilization methods such as amphiphilic polymer encapsulation and ligand substitution are used to transfer quantum dots in the aqueous medium. Our quantum dots were hydrophilized with a ligand substitution. Triactylphosphine groups were replaced by a thiol-containing copolymer, vinylpyrrolidone with maleic anhydride and ethylene glycol methacrylate. With the result, hydrophilic carboxylic groups are combined on the quantum dot surface. To improve optical characteristics and reduce biotoxicity, quantum dots are covered with the semiconductor shells with a width of the energy gap more than the quantum dot's core. Zinc sulfide and cadmium sulfide and other semiconductors can be used as shell materials. The size of hydrophilized quantum dots is about 16–18 nanometers. The basis of aqueous colloidal synthesis is chemical reactions between semiconductor precursors in aqueous solution. The main advantages of this method are the relative simplicity and lack of need for complex equipment and the ability to cover the quantum dots with a hydrophilic stabilizer immediately. which is certainly an important indicator for quantum dots used in immunochromatographic analysis. However, quantum dots data usually have lower quantum yield and a wider luminescence peak. The synthesis scheme is presented on the slide. Aqueous colloidal synthesis is used to produce quantum dots stabilized with thioglycolic acid, L-cysteine, and mercaptoethylamine. The size of the quantum dots data was estimated with using an empirically derived formula presented on the slide and dynamic light scattering method. Comparison of the results shows that the size of quantum dots obtained with dynamic light scattering is several times larger. This happens due to the fact that with this method it is possible to determine the hydrodynamic size, which includes quantum dots, stabilizer, and solvent shell. The best optical properties had cadmium telluride quantum dots covered with thioglycolic acid, which quantum yield is 28%. The maximum luminescence length was at 615 nanometers. The width of the luminescence peak at half height was 65 nanometers. To improve the optical properties and stability of cadmium telluride, quantum dots were covered with additional layers of semiconductors. Scheme of shell buildup is presented on the slide. Using the luminescence spectra of these quantum dots, we can observe that during the coating process, the luminescence peak shifts to the long wavelength region, which is associated with change to the quantum dot's energy structure. Namely, when covered with an additional layer of cadmium selenide, the redistribution of charge between the core and the shell layer occurs. Further coverage with cadmium sulfide and zinc sulfide layers restricts charge carriers within the cadmium telluride cadmium selenide layers, as well as changes in the quantum dot's crystal structure, which is the reason for the bathymetric shift. Thank you for your attention.
Hello, ladies and gentlemen. I would like to bring to your attention of our work on the application of quantum dots as fluorescent labels of proteins in immunochemical analysis. The relevance of the scientific field is confirmed by the steady growth of publications on the topic quantum dots in diagnostic, chemical, and immunochromatographic analysis, according to Scopus. Currently, the following markers are used as protein labels in immunochromatographic analysis. Particular attention is drawn to quantum dots, which are semiconductor nanocrystals with unique optical properties. The optical properties of quantum dots can be varied by changing the size and material of its core during synthesis. For the purpose of immunochromatographic analysis, the visible and near-infrared optical ranges are especially important, since it is in the near-infrared region that the transparency window of blood and other biological objects is located. The principle of immunochromatographic analysis is to detect biomarkers of the disease, using bioregions as, for instance, mono or polyclonal antibodies, recombinant proteins, and so on. Thus, specific molecules connected to a fluorescent label that provide a highly sensitive test system for the detected marker of the disease. In essence, these tests run the liquid samples along the surface of a pad with reactive molecules that show a visual positive or negative result. Lateral flow tests can operate as either competitive or sandwich assays. In this work, we use a variant of sandwich assays. Conjugation quantum dots with the biomolecule can be implemented in various ways, such as covalent, non-covalent, and bioorthogonal linking. Thus, as a model biomarker in this work, we use the virus of Augeski disease. Monoclonal antibodies to its glycoprotein Gb were conjugated to the quantum dot surface, fluorescing in the near-infrared range by the carbodiimide method under mild conditions, with the formation of a covalent bond. The essence of the carbodiimide method is that carbodiimide activates carboxyl groups on the quantum dot surface, allowing them to bind to amino groups of proteins, forming a peptide bond. To avoid hydrolysis of the ester group, succinimide is added to reaction mixture. Analysis of the dependence of zeta potential on pH shows that during conjugation, the isoelectric point is shifted, which is caused by a change in the charge and the structure of the double electric layer of quantum dots. This may indicate the presence of antibodies on the quantum dot surface. The average hydrodynamic size of multilayer quantum dots was 20 to 15 nanometers. After conjugation, the average size increased to 30 to 40 nanometers. This increase may be caused by presence of antibodies on the surface of quantum dots too. At the same time, the quantum yield of quantum dots after conjugation decreased from 18 to 45%. To optimize the immunochromatographic system, which includes a strip and reader, the distribution of quantum dots conjugates along the strip after completion of immunochromatographic process was studied. The scan of the test strip shows that conjugates are not served on analytical pad, except for the test and control zones. In this case, the excess conjugate is mainly located on the weakened pad. A model of a fluorescent reader was designed, using which the calibration curve was constructed. As can be seen from the graph, there is a linear relationship between the fluorescent analytical signal and the antigen concentration up to a concentration of 0.8 micrograms per milliliter. This allows quantitative detection of antigens in the analyzed samples. Thank you for your attention.
Hello, my name is Sagela. I am pleased to submit the present report on the topic physicochemical basis electrophoretic behavior of the quantum dots. Quantum dots are nanometer-sized luminescent semiconductor crystals and have unique chemical and physical properties due to their size and their highly compact structure. They emit different wavelengths over a broad range of the light spectrum from visible to infrared, depending on their size and chemical composition. As a rule, quantum dots are composed of a core, a shell, and a stabilizer. They have such advantages as high photostability, a high quantum yield of fluorescence. The methods of microscopy and X-ray diffraction are most often used to characterize quantum dots, which make it possible to determine the size, shape, and phase composition of nanocrystals and spectroscopy methods. In recent years, the capillary electrophoresis method has been demonstrated as an efficient and reliable method for the separation and analysis of various nanoparticles. In the method of capillary electrophoresis, substances are separated based on the difference in the electrophoretic mobility. The use of small capillaries significantly reduce reagent and sample volumes. The advantages of this method include high separation efficiency, low detection limits, ease of sample preparation, and low cost per analysis. The aim of this work was to study the possibility of characterizing quantum dots and develop a method for analysis by capillary electrophoresis. The object of research were hydrophilic quantum dots synthesized on the basis of the Department of Chemistry, New Technologies and Materials in Dubna University. As is known in the capillary electrophoresis method, the electrophoretic mobility of particles is determined by the radius of charge. Therefore, these nanoparticles were characterized by a dynamic light scattering method. Moreover, the dependence of the zeta potential of pH was constructed according to the value of which the pH range was determined in accordance with which the buffer for electrophoretic determination by capillary zones electrophoresis was selected. It was decided to resolve the electroosmotic flow by introducing a surfactant into the working electrolyte due to the fact that the quantum dots under study mostly had a negatively charged surface. Cetyl trimethyl ammonium bromide was chosen as a modifier when added the electroosmotic flow direction reserved towards the anode. As a result, we observed a significant reduction in the analysis time of quantum dots relative to the migration time in a board buffer that does not contain surfactants. However, the peaks also expanded, which was a consequence of a decrease in the efficiency of electrophoretic separation. A study was made of the influence of the concentration of the leading electrolyte and the surfactant additives on the electrophoretic mobility and the formation of the substance zones to increase the efficiency. Thus, at the highest surfactant content in the borate buffer, the total electrophoretic mobility of quantum dots are increased. By varying the concentration of the supporting electrolyte, we could observe both the broadening of the migration zones in the 30 millimole per liter borate buffer and the narrowing of the peak, and therefore an increase in efficiency with a more diluted 10 millimole per liter borate buffer. Further, we investigated the effect of voltage on the electrophoretic mobility of quantum dots. From the obtained electrophoregrams, it can be seen that increasing the voltage reduces the analysis time. The slide shows electrophoregrams for quantum dots or various compositions obtained under conditions for which the best efficiency was observed. The sequence of migration of the quantum dots under study is consistent with the data of the dynamic light scattering methods. The longest migration time is typical for multi-layer quantum dots with a large size. According to the data from the electrophoregrams, the mobility quantum dots mobility was calculated, the values of which are presented in table 3. The determination efficiency was characterized by the number of theoretical plates and the height equivalent to the theoretical plate. Thus, the optimal conditions for determining quantum dots with high efficiency and short duration of analysis were selected. Capillary electrophoresis was used to study the efficiency of quantum dots cleaning and their stability. The electrophoregram shows a decrease in the intensity of the peaks of impurity compounds, which we observed after purification, which indicates the effectiveness of this procedure. And this slide shows electrophorograms obtained immediately after the synthesis of quantum dots and after 3 days when stored in an aqueous solution. The observed shift in the migration in the quantum dots migration time on electrophorograms may indicate the process of the aggregation. During the work, the following results were obtained. The influence of the conditions of the electrophoretic process on the parameters of, quantum dots migrations was studied. A method for the analysis of quantum dots, various quantum dots by capillary zones electrophoresis has been developed. It is shown that the migration time of quantum dots depends on the surface charge and their size. Studies of the stability of CdTe quantum dots have been carried out. It has been shown that the change in the type of electrophoregrams can be used to use the efficiency of cleaning quantum dots and the processes of their degradation. An increase in the migration time of quantum dots of the same species indicates the aggregation. Thank you for attention.
Hello colleagues, my name is Vladislav Kinev and I am from Dubna State University, Russia. I will present you a short report on the topic of hybrid perovskite bulk crystal synthesis by temperature lowering method. Compounds with a perovskite structure have been known for a long time, but hybrid halide perovskites, which exhibit unique semiconducting properties, have attracted great interest in the scientific world. It quickly became clear that these materials, due to the high mobility of electric charge carriers and the short lifetime of electron hole pairs, can be used to create highly efficient devices, such as thin-film solar cells, light-emitting diodes, photosensors, lasers, field effect transistors, and etc. In a fairly short period of time, the record efficiency of perovskite solar cells reached 25%. When we talk about solar cells, the perovskite layer is usually a thin film. Perovskite thin films can be obtained by various methods. Methods for forming films from precursor solution and vacuum deposition methods have gained great popularity among researchers. However, the main challenge is to obtain a crystalline phase with excellent stoichiometry. This significantly affects the semiconducting properties of material. Due to this, we became interested in using the vacuum flash operation method. Flash operation method is based on the fact that film deposition is carried out by continuous vacuum evaporation of small portions of multi-component compounds. Crystals with a size of about 100 microns are placed inside the dispenser and controlled by the outlet. The evaporator is heated to the temperature required for the flash operation of all particles. The main idea of the method is to preserve the stoichiometry of the initial crystals of the substance. To use this deposition method, we synthesized bulk perovskite crystals. The most successful result was obtained using the temperature-lowering method. This method is suitable for the growth of perovskite crystals in which the solubility of organohalide perovskites in the corresponding acid halide solvents is moderate at room temperature, but changes significantly with increased temperature. Bulk crystals of methylammonium lead triiodide were grown by lowering the temperature in an hydroiodic acid solution. As a result, black-gray bulk perovskite single crystals were obtained. To identify the crystal structure of the obtained crystals, an X-ray phase analysis was carried out, and a diffraction pattern of tetragonal perovskite crystals was obtained. Using the crystals we obtained on the basis of the Russian-Armenian University by Georgian Vladimir Aramovich, a perovskite film was deposited by the flash operation method. Perovskite film were deposited on a glass substrate heated to 100 Celsius degree. To study the characteristics of the obtained film, the transmission and reflection spectra were obtained, and the dependence of absorption on the energy of incident radiation was plotted. According to the literature data, the band gap of such perovskite is 1.5 f. The value obtained by us doesn't correspond to this. This is possibly due to a number of reasons. Violation of stoichiometry due to the high temperature of the substrate, or violation of stoichiometry as a result of degradation of both the starting material and the already deposited film as a result of contact with air and under the influence of elimination. We hope to resume international cooperation soon and achieve better results. Thank you for your attention. Goodbye and stay safe.
Dear colleagues, the theme of my lecture is multivariate data analysis methods for the selection of promising hydrosol phase change materials. One of the most important world modern problems is the development of energy-effective, cheap and environmentally friendly technologies for heating and hot water supply. Modern trends in the world industrial development is increase the energy consumer costs and using of supplied energy for heating. For this reason, the creation of thermal energy storage devices is an important task. The diagram presented in Figure 1 shows the entire list of materials potentially suitable for heating storage. Then sensitive materials as water was heat capacity is much less, which is illustrated in Figures 2 and 3. Among the proposed materials, salt hydrates are the most effective to its optimal working temperature characteristics, ensuring operability in temperature ranges close to room temperature, that is from 0 to 100 degrees Celsius. A large number of requirements are imposed on selection of phase change heat storage materials, including salt hydrates. To select optimal and most effective phase change material, investigators are must to consider more than 24 quality criteria at the same time. However, according to the analysis of more than 500 literary sources, about 160 salt hydrates, not a single substance can be satisfy quality selection criteria. Therefore, until recently, salt hydrates were considered the most difficult problem in phase change material research. Classical mathematical approaches are required with the help to selection the most effective salt hydrates based on the choosing quality criteria. Exciting approaches are subjective due to the wide range of materials applicability in the heat storage system. Each industry requires materials with its own phase transition temperature range, so each application requires repeated data analysis, the results of which are also judged subjectively. The phase change material selection methods used in natural science can be conditionally divided into several groups. There are multi-criteria decision methods, which include AHP, ANP, TOPSIS, electro method. Multivariate data analysis methods are factor analysis, linear and quadratic discriminant analysis, SIMCA, PLC, and Ashby methods. Factor analysis was selected for materials ranking as the most common and available methods. It's present in a large number of software packages. All quality criteria can be divided into several categories. There are quantitative and non-quantitative criteria. The first stage, the stage of pre-factorial selection of materials. Materials are selected manually based on a number of quantitative and non-quantitative criteria that are not analyzed in the framework of factor analysis due to their critical significance. There are non-quantitative criteria: environmental safety, corrosion resistance, toxicity, volatility. Quantitative criteria: melting point, cost. On their basis, salt hydrates are selected that are safe for use, cheap, and have a phase transition in the temperature range from 0 to 100 degrees Celsius. The remaining non-quantitative parameters are removable at the next materials analysis and improvement stage and are considered at the factor analysis stage and material post-factor selection. There is a problem associated with the data inconsistency, and therefore the characteristics of the same materials may differ significantly from different authors. A global solution to this problem involves local data reconciliation, in which the parameters are averaged in several stages. All literary and experimental values are classified into groups in which all values of the same parameter obtained in the same way fall into one group. This group of values is average. After that, that set of mean values from different groups is averaged among themselves. In our calculation, we used a simplified scheme in which the mean values obtained between the correlated data were used as parameters. This simplification is due to the fact the literature data are not used for experimental work and presuppose the choice of materials, the parameters of which are relative to each other in different sources. Another problem is that many salts hydrate lack a certain amount of physicochemical quantities, and therefore it is impossible to analyze substances across the entire list of data. Therefore, factor analysis was carried out in several stages. At the first stage, the most complete sample of 25 salt hydrates was analyzed by 4 parameters. Molecular weight was used as an alternative to the parameter's density, since it's not known for all crystal hydrates. It's assumed that molecular weight directly affects density and volume, so its significance correlates with that of density. The graph of accounts shows that the most promising are crystalline hydrates, magnesium nitrite hexahydrates, sodium carbonate decahydrates, sodium acetate 3 hydrates, and barium hydroxide. The table shows that factors 1 and 2 have high factor loadings for the variables molecular weight and density of heat accumulation. All parameters analyzed of salt hydrates required a decrease in the amount of quality criteria. Therefore, the analysis was carried out in order to identify the factor loading correlation between the current and previous analysis. It turned out the more great importance material cost and density, and they correlates with molecular weights. In the next analysis studies, after the parameters regrouped, it turned out the largest factor loads in the factor 1 and 2 are density and density of heat accumulation introduced. At the stage of post-factory material selection, non-quantitative and quantitative parameters are distinguished that seriously affect the material heat capacity with the temperature range from 0 to 100 degrees Celsius. These parameters include hypothermia, phase segregation, cyclic stability, and congruent melting. These parameters are removable, therefore they are not considered as determined at the prefactorial selection stage. The selection of promising materials using factor analysis takes place in several stages. In prefactor, we select materials according to critically important quantitative and non-quantitative parameters to select effective phase change material. In factor analysis, materials are examined according to a number of selection quantitative criteria. In the study, we also choose the most influential criteria. In addition, post-factor selection of materials in which salt hydrates are selected according to critical non-quantitative and quantitative criteria that can be improved. This approach allowed use to select perspective of salt hydrates as phase change materials. Further experimental work will show how rational the choice is, but even now we can say that the selected salt hydrates have a high potential. Thus, zinc nitride hexahydrate melts congruently. Barium hydroxide in its temperature range from 60 to 70 degrees Celsius is the only suitable material. The rest of the materials have high enthalpies of melting, but also have high supercooling and congruent melting, so that further use in the pure form is difficult, and further research is focused in finding additives that improve the characteristics of salt hydrates. This research was carried out with the support of the Foundation for Assistance to Small Innovative Enterprises. Thanks for your attention.
Bismillahirrahmanirrahim. Starting in the name of Allah, the most beneficent and the most merciful. This is me, it's my picture. So, I am Rafiuz Zaman Brohi from Pakistan. I am a PhD scholar of chemistry at University of Sindh, Jamshoro, Pakistan. So, today I am going to present my lecture on behalf of the second International Conference on Molecular Modeling and Spectroscopy, which is organized by National Research Center, Cairo, Egypt. So I am very much thankful to Professor Dr. Midhat Ibrahim. He invited me in this conference, and he gave me opportunity to present my work in this conference. So thank you very much, Dr. Midhat Ibrahim. The title of my presentation is Novel Bimetallic Nanoparticles for Absorption of Mercury 2 from Drinking Water, Adsorption Experiment and Computational Studies. This is my title of today's presentation. These are the contents of a presentation: introduction, objectives, methodology, results, and conclusion. In introduction, first of all, the mercury toxicity. According to US EPA, United States Environmental Protection Agency, mercury in drinking water has potential to cause kidney and central nervous system damage in humans. So according to US EPA, the mercury can damage the kidneys and central nervous system in the humans. There are different forms of mercury in the water. First one is metallic mercury, then mercuric form, that is Hg2+. The third one is mercurous, Hg1+, and finally the methyl mercury. So these are the various forms of mercury which are present in the water bodies, natural water bodies. WHO guideline of mercury in drinking water is 6 ppb, that is equals to 0.06 ppm. So this is the WHO guideline. This is the maximum permissible limit of mercury in the drinking water, that is 6 ppb. It should not exceed from this concentration. So this slide, this figure shows the mercury cycle in the environment, how mercury is moving in the various segments of the environment. So you can see in this figure the mercury from the power plants. There is a combustion of fossil fuels. The elemental mercury is emitted from the combustion of molecules, combustion of the fossil fuels in the power plants, and also from the volcanic eruptions. The elemental mercury is emitted in the atmosphere, in the air, from these two sources. Then it is oxidized in the mercury 2 form. Mercury 2 form is the inorganic form of mercury, and this mercury 2, by the various different processes, this mercury 2 again introduced into the water bodies, and in water bodies this mercury 2 is accumulated in the bodies of aquatic living things like fishes and planktons and other fish and other aquatic organisms. This mercury 2, inorganic mercury, in the bodies of fishes and aquatic organisms, it converts into the organic form that is more toxic, and that form is methyl mercury and dimethyl mercury. So this figure is basically the representation or the cycle of mercury in the food chain in the environmental segments. Study objectives. The objectives of my study are to fabricate novel bimetallic nanoparticles. So I have prepared the bimetallic nanoparticles of manganese and copper. The second objective is to remediate mercury from drinking water using nanoparticles by adsorption method. And the third objective is to carry out computational studies of mercury adsorption on fabricated nanoparticles. These are the major objectives of my study. Methodology: how the nanoparticles, bimetallic nanoparticles of the manganese and copper were prepared. So in first step, the manganese and copper salts were mixed and dissolved in the water. And in second step, the solution was stirred and the reducing agent, that is sodium borohydride, that was added into the mixture drop by drop. Then finally, after 2 hours of stirring, the black particles were observed, and these particles were the bimetallic nanoparticles of manganese and copper, which were then filtered and washed several times and finally dried in the oven. These are the SEM images of the manganese copper bimetallic nanoparticles. The SEM images. Mercury removal process from water. Batch experiment was performed to examine the absorption of mercury on manganese copper nanoparticles. So in this study we conducted the batch experiment and we examined the removal of mercury and adsorption of mercury on manganese copper bimetallic nanoparticles. For this experiment 10 ppm solution was added with the 10 mg of nanoparticles and was checked for 15 minutes and filtered. After filtration, finally the mercury residues was determined using cold vapor atomic absorption spectrophotometric method. Results. The total 95% removal of mercury was observed from water sample. The water sample which was taken, which contained the mercury, from this sample the 95% of mercury was removed successfully. The adsorption capacity observed was 400 milligrams per gram. So the adsorption capacity of the nanoparticles for mercury that was observed was 400 milligrams per gram. Adsorption process followed the Langmuir adsorption isotherm with R square value of 0.99. So we performed the different isotherms and it was observed that the Langmuir isotherm was most fitted for this study. Langmuir, Friendlich and Sips isotherm were studied and we found that the Langmuir isotherm has the good value R square value from the as compared to other isotherms. EDS characterization. EDS basically it's a technique of characterization which tells us about the elemental composition of any surface. What elements are present on the surface of any adsorbent. So we carried out the EDS characterization of the nanoparticles after mercury adsorption. So this EDS results shows that there are the good peaks of manganese and copper, which shows that the manganese copper nanoparticle was formed successfully. And after adsorption, you can see the mercury peaks in this graph. So which shows the successful adsorption of mercury on these nanoparticles. Computational models. Computational models were performed using Gaussian 0-9 package. So we use the Gaussian package, 0-9 package for computational study. Different models were drawn. Number one, the structure of manganese were drawn separately. Number two, copper structure was drawn separately. And number three, the combined structure of manganese and copper was drawn. The combined model of manganese and copper was drawn. And after that, the mercury adsorption, means interaction of mercury, was also studied by computational models. First, we studied the interaction of mercury on manganese surface. Then we studied the adsorption of the mercury on copper surface. So these are the molecular models. Number one shows the manganese model and number two shows the copper model. These are two separate models of manganese and copper. After that, this is the combined manganese copper surfaces, means we have combined both the manganese and copper models. We got this structure and this model. The blue for the manganese and red for the copper. And in this model you can see the interaction of mercury on the copper surface. So this mercury has the 6 water molecules surrounding it. because the mercury 2 ion has capacity to attract the 6 water molecules. So water molecules are also shown. So this model shows the interaction of mercury, which is surrounded by 6 water molecules, and it is interacted with the copper surface. And finally, this model can show the interaction of mercury on manganese surface. Conclusion. Experiment study suggested excellent removal of toxic mercury from drinking water. So our experiment study was excellent and showed the good results for removal of mercury using manganese copper bimetallic nanoparticles from drinking water. The computational modeling study suggested that mercury forms strongly bond with manganese surface than copper surface, which indicated that the higher concentration of mercury was adsorbed on manganese portion rather than copper. So our calculated model indicated that the mercury adsorption was maximum observed on the manganese because the mercury formed strong bonds with the manganese rather than copper. Thank you very much.
Thank you for all participants in this session, and we will make a short time for any question if someone have these